What is resultant force? Resultant force is combination of two or more forces. When two or more forces join together, combine together, that combination is called a resultant force. How to find a resultant force? So how to find, or how we can find a resultant force if forces are acting in same direction? How to find a result? We will simply add them. So whenever the forces are acting in same direction, you will simply add them to get the resultant force. So an object is there, and this object is on the ground. A force of 7 Newton and a force of 3 Newton is acting on the object. How to find the resultant force? So how I can find a resultant force? The force with the resultant of these two forces which act on the object, because these two forces are acting in the same direction. So how I can get the result? That will be equal to 7 plus 3 equals to 10 Newton. And what is the direction? The direction is towards right hand side, because both are towards right, so both are positive forces I took, and final answer is positive, so it means the resultant is acting towards right hand side. So when two forces, or it can be more than two forces, but if all of them are acting in the same direction, to get the resultant we will simply add them. But if two forces are acting in opposite direction, so to get the result, what we will do, we will subtract them. So if two or more forces are there and they are acting in opposite direction, so if you want the resultant of these two forces, we can subtract. A 7 Newton is towards the left and 10 Newton is towards right. So basically, either you subtract or you consider their sign. So 10 minus 7, which is equals to 3 Newton. And I'm getting a positive answer, so it means the direction is towards right hand side. So when two forces are acting in same direction, to get the result, you will add. If they are acting in opposite direction, to get the result, you will subtract them. The third method, if the two forces are making certain angle, if the forces are making angle with each other, the method which we can use, there are three ways we can find the result. We can use a scale diagram, we can use a triangle method, or we can use parallelogram method. Look, if you want to solve, you can solve in this manner. Is always the greater force minus the smaller force to get the resultant force. So this 10 is greater than 7. That's why I took a greater force minus smaller force. Because the direction of the resultant is always towards the direction of the greater force. So if the two forces are making certain angle, then we can use, like example, two forces are there. One is 3 Newton, another one is 7 Newton, and making angle 20 degrees with each other. So 7 Newton and 3 Newton are making angle 20 degrees with each other, and I want to find the resultant of these two forces. So for this resulting, there's a separate, I will explain all these three methods in detail, but not now because the whole topic is a bit different. Later I will explain this scale diagram, triangle method, and parallelogram. But the idea is that if two forces are acting in same direction, you will add. If they're acting in opposite direction, you will subtract to get the resultant. If they are making certain angle, then three methods can be used, either a scale diagram, triangle method, or a parallelogram method. That all three methods I will explain, but not now, because first I want to explain another topic, which is about force and motion. And basically it's about resultant force and motion. So resultant force and motion, an object is there. This is an object. And the object is at rest. Initially at rest. So this object in the beginning, it was at rest. And you pull this object towards right with the force of 5 Newton, and another person pull in opposite direction with a force of 5 Newton. The question is, what is the resultant force here? What's the resultant force on this object?
0.
So resultant force is 0 because the plus 5 and minus 5, that will make 0. Okay, so resultant force is 0. What about acceleration? Is there any change in speed? What happened to state of the object? This object will move. Is there any movement you will observe? If the resultant force is 0, if there is no result, there are forces, but the resultant force is 0. So what we'll observe? We'll observe this object will remain at rest, or no change in speed, or it will have no acceleration. So whenever the resultant force on the object is 0, the object will remain its own state. Same thing, if there was a moving object, this object was moving towards right, and you're pulling this object by a force of 10 Newton, and the frictional force is opposing its motion with the same force of 10 Newton. What happened to this object? What is the resultant force? First thing, what's the resultant force in this example? A 10 Newton towards right and 10 Newton is towards left. So what is the resultant force? So there is no resultant force, or you can say the resultant force is 0. So when the resultant force is 0, what you will observe, this object will continue to move with constant speed. If I say speed of the speed also, if I include that speed of this object was say 5 meters per second. So what will happen? This object will continue to move with constant or uniform speed. And it does not have any acceleration. No acceleration means no change in speed. So the idea is that whenever the resultant force is 0, if there is no resultant force acting, forces are there, but the resultant force, in both examples, there are forces, but the resultant force is 0. So whenever the resultant force is 0, if the object is stationary, the object will remain stationary. If an object is moving, it will continue to move with a constant speed. Is it clear, the first idea, that if resultant force is 0, the object will not change its state, the object will not accelerate, or acceleration of an object will be 0. I'll take the screenshot. Motion here, movement refers to motion. Like you can use the term motion or you can say movement. This is a motion of an object or movement of object. Motion or movement having a same meaning. So this object is moving towards right, and there are forces. One is a driving force and another one is the frictional force, which is opposite to direction of the driving force. So this object will not accelerate, or this object will not change the speed. It will continue to move with a constant speed or uniform speed of 5 meters per second. Same thing, if there's an object this is a continuation of resultant force and motion. So an object is there. And this object was moving. Its direction of motion is towards right. And it was moving with a speed of 5 meters per second. And you applied a force of 7 Newton and the friction was 2 Newton. What is the resultant force? A force of 7 Newton is towards right and force of 2 Newton is towards left. What is the resultant force on this object? So resultant force on this object is 5 Newton. And what is the direction? So 7 minus 2, which is equals to 5 Newton. And what is the direction of this? It's towards right hand side. So the direction of the motion is towards right and the direction of the resultant force is towards right. So if direction of resultant force and direction of motion are same, what will happen? The object will accelerate. So when we say this object will accelerate, it means the speed of object will increase. So if this object all the points, the force which is acting, you're applying a force of 7 Newton. So you applied a force of 7 Newton, the friction was 2. You applied a force of 7 Newton, the friction is 2. You continue applying force of 7 Newton and the friction remain 2. So what is the resultant force at this point? The resultant force is 5 Newton. What is the resultant force? That's also 5 Newton. If resultant force is not changing, if resultant force is constant, the acceleration will also be constant. The change in speed will be constant. So example, if I say the acceleration of this object was 10 meter per second square, and originally the speed at this point was 5 meter per second. So if acceleration is 10 meter per second square, speed is 5. So after 1 second, what will be the speed? The speed will be 15 meter per second. Then after another second, what will be the speed? It will be 25 meter per second. So what happened? This object experienced a resultant force, a constant resultant force. What is the resultant force? 5, 5, 5. An example, there's a way to calculate acceleration, but I took here a random number. So example, if this object was having an acceleration of 10 meter per second square, so every second it accelerates or changes speed by 10. So what will be the speed? If originally it was 5, after 1 second, what will be the speed? It will be 15. Then after another 1 second, what will be the speed? 10. Because the acceleration of this object is 10, which shows that every second the speed will change by 10. Is it clear? So whenever the resultant force is constant, if resultant force is constant, the object will have constant acceleration, or you can say constant change in speed. Is it clear? The concept that whenever the resultant force on the object is same, the object will have a constant acceleration. When we say constant acceleration, in this example, I took acceleration as 10 meter per second square. So every point, its acceleration will be 10 meter per second square, or speed will change by 10 meter per second. Any doubt in this? Take the screenshot. If any topic you have difficulty or you have doubt, feel free to ask your doubts or questions. the formula which relates force, mass, and acceleration which is the F force equal mass multiplied by acceleration, where F is a force, M is a mass, and A is acceleration. So F is equals to ma. This formula can be used to find a relation between this formula is used to show a relation between force, mass, and acceleration, and you can learn from this triangle. So F, M, and A. So if we need force, it's mass into acceleration. If we need mass, it's force divided by acceleration. And if we need acceleration, it will be force divided by mass. Then what is the relation between force and acceleration if mass is constant? And this is a resultant force basically. So the relation between force and acceleration, they are directly proportional if mass is kept constant. So you have two objects of same masses This one is 3 kg. This one is also 3 kilogram. A force of 100 Newton and force of 98 Newton in the opposite direction. The other one, 10 Newton force and 2 Newton force. What is the resultant force on object A? A force of 100 is towards right and force of 98 is towards left. What is the resultant force on this object A?
2.
So the resultant force is 2 Newton on object A. What is the resultant force on object B? A 10 Newton towards right and 2 Newton is towards left.
8.
8 Newton. Now the question is, which object will show a greater change in speed or which object has greater acceleration? So which of them will have a greater acceleration or greater change in speed, A or B?
B.
So B will have a greater acceleration or greater change in speed, or B will change its speed much quicker as compared to A. Why? Because if two objects have the same mass, then the one which feels the greater resultant force will have a greater acceleration or change in speed. You can also use a formula to get this relation or the value, because you have the formula F is equals to ma. So A is equals to, expression is force divided by mass. So force, what is the force? You don't substitute 198, you always substitute resultant force in this formula. So resultant force is 2 and the mass is equals to 3. So 2 divided by 3, 0.66 meter per second square. And when I find the acceleration of this, again it will be force divided by mass. So force, it's 8, the mass is 3. So this will be 2.3, 2.66 meter per second square. So you can see or check the one which is having greater resultant force will have a greater acceleration. So acceleration of a B is higher or more than acceleration of A because greater resultant force is acting on B. That's why if both have the same masses, then you compare the resultant force. Is it clear, this concept? The relation between resultant force and acceleration if mass is constant. Take the screenshot. Then the relation between resultant force and mass if acceleration is same. If you want same acceleration, so the relation between resultant force and mass, they're inversely proportional. The one which is having less mass or lighter, sorry, because F is equals to ma is there, so the one which is having a greater mass will need a greater resultant force to produce the same acceleration. So you have two objects of different masses. You want the acceleration of this object to be 2 meter per second square. You need acceleration of the second object also 2 meter per second square. The mass of this object is 10 kg. Mass of this object is 2 kilogram. So what is the resultant force if I want to produce an acceleration of 2 meter per second square? What should be the resultant force on this object? So we have the formula F is equals to ma. So force is mass multiplied by acceleration. Mass is 10 and acceleration is 2. So 10 multiplied by 2, which is equals to 20 Newton. Same way for this one, the mass multiplied by acceleration. So this mass is 2 and acceleration is also 2. So I just need a 4 Newton force. So to accelerate heavy object, so 2 multiplied by 2 will make it 4. So to accelerate heavy object, we need a greater resultant force as compared to lighter object. So it's the same thing like if you want to move a truck or if you want to push a car, definitely a truck requires greater amount of force to accelerate or to change the speed as compared to a car. So here a resultant force, you required a resultant force of 20 newtons, and this one you required a resultant force of 4 Newton. So if you want to produce same acceleration, for objects of different masses, Heavy objects require greater resultant force compared to lighter object. So if you want to produce the same acceleration for objects of different masses, heavy object require greater resultant force as compared to lighter object. Take the screenshot, then the last part of this relation between force, mass and acceleration, in which we relate acceleration with mass. So the relation between acceleration and mass, if resultant force is same. So if same resultant force act on the object, and we want to find a relation between force, mass and acceleration, between mass and acceleration, so they're inversely proportional. So lighter objects will have greater acceleration than heavy objects. So two objects of different masses are placed on the ground. The resultant force which act on object A is same as resultant force act on object B. Say a resultant force of 10 Newton was there on A, a resultant force of 10 Newton is there on B. Mass of A is 2 kilogram and mass of B is equals to 20 kg or 20 kilogram. So which one have a greater acceleration or which one have a greater change in speed? So you can find as well, you have the formula F is equals to ma. So A is equals to F divided by m. So resultant force was 10 and mass is 2. So the acceleration for this object is 5 meter per second square. For this object, if we need an acceleration, it is F divided by m. So force is 10 and mass is 20, which is equals to 0.5 meter per second square. So you can see here, the object which is lighter have greater acceleration as compared to heavy object. So when same force is applied, on two different objects, the lighter object has greater acceleration or change in speed. So when you apply the same resulting force or same force on two different objects, the object which is lighter will have a greater resultant force. So is it clear, the concept? So we can, the object which is lighter will have a greater acceleration if we same resultant force act. So lighter objects have greater acceleration than heavy objects, or lighter objects will show a greater change in speed as compared to heavy objects. So this formula is important. F is equals to ma. You will find a question in which you use to identify either a resultant force or a mass or acceleration. Any doubt till now related to the concept of a resultant force? So a resultant force can be calculated by either addition, subtraction, or a scale diagram. By a scale diagram, and if there is no resultant force, there is no change in state. The object, if it's a stationary object, it will remain at rest. If it's a moving object, it will accelerate or have a constant acceleration. If an object, there's a constant resultant force is there, it will have a constant acceleration or constant change in speed. And how we can find the relation between force, mass, acceleration? F is equals to ma. If two objects have the same masses, the one which has greater resultant force will have a greater acceleration. And if two objects have the same acceleration, so the heavy object required greater force to accelerate with this, to have a same acceleration as compared to lighter objects. And if two objects have different masses and experience the same resultant force, so lighter object will have a greater acceleration than heavy objects. So same way, as we know, a speed time graph so using a speed time graph, how we can identify a force? Basically, as we know, a speed time graph, what slope represent? Slope represent acceleration. So slope of a speed time graph refers to or equal to acceleration. So on y-axis we have speed and x-axis we have time. And the graph, the shape of the graph, it was like this. What happened to slope? What happened to slope of this line? Increasing, decreasing, constant, or zero?
Increasing.
So slope is increasing here. So if slope is increasing, what happened to acceleration? Acceleration is also increasing because the slope of speed time graph represent acceleration. And I told you that what happened to acceleration is same thing happened to resultant force. So what happened to resultant force? The resultant force will also increase. So acceleration and resultant force are directly proportional. So what happened to slope? Same thing happened for acceleration, and what happened to acceleration? Same thing happened to resultant force. So they are interrelated. If the question is using a graph, identify what happened to the force. So you check the slope, you will identify what happened to acceleration, and using acceleration, you can identify what happened to resultant force. Is it clear?